Okay, let's talk about the zirconia O2 sensor and testing it. Here's the O2 sensor. Before you do anything, the O2 has to be switching like you see here. 100 to 900 millivolts, it needs to be switching. It's an O2 sensor switching from low voltage. Let me back up. Remember, this is 0.4. Imagine an imaginary line going across here. Right? Anything below this is a lean condition. Below that line. 450 millivolts and below, lean. Above 450 millivolts, rich. The indication to the PSIM. It indicates to the PSIM either a rich condition or a lean condition. The PSIM job is to do the opposite, to try to balance the airflow mixture out. For example, if I'm down here as lean, it's giving the PSIM a lean indication. It's going to add fuel to try to bring it back up towards this way past 450. When it says up here and it's reading like say 800, 900 millivolts, it's going to compensate. The command is going to be lean and bring it back down, and the cycle repeats itself. That's when you know that's part of fuel control, closed loop. You want to see one of the things you want to see the O2 sensor is switching, indicating the PCM is listening to the O2 sensor, and the O2 sensor is picking up O2 content from the exhaust. So first off, before you test it, the O2 sensor should be switching. Next, to add propane to it, it should go up to its maximum number, 800, 900 millivolts. It should rise. Okay, if you add propane to the induction system, the O2 sensor does not move, it's defective. So I add propane. If propane is fuel, it should rise to its maximum number. Now when it's up there, let me back up. I forgot we're testing this. So we add a propane. At this point right here, the computer is going to try to lean out the air fuel mixture because, remember the command? Rich condition, or rich indicator, lean command. So when I remove the propane, I should see the response of the O2 sensor to a lean command from the computer, which is this. At this point here was rich. The computer is trying to lean it out. We're adding propane right here. Remember, we're the ones adding the propane. We turn the propane off, it falls lean. And that's the command from the computer trying to take care of this condition here. Then what we're going to do, we're going to snap it and measure this rise time. That rise time should fall under 100 milliseconds. Anything above that indicates a lazy O2 sensor. Look at this. This is RPM. This is O2 sensor parameter. This is a scan tool. This was a lab scope. This is a scan tool grafting the meter. This is a scan tool actually grafting it. And this is a lab scope hooked up to the sensor. So we add propane, we see the voltage go up. We want rich. At that same time I want rich, this is my lean command. My short-term fuel trim is a direct response to the O2 sensor. Okay? When this goes rich, my computer should try to lean it out. I can see that by watching my short-term fuel trim. That's a direct response to the O2 sensor. Now we're going to measure. Here we're going to use two cursors to try to measure how fast it responds. Cursor 1 and cursor 2. 1, 2. Delta time. The difference between the two cursors. And right now, 2 is set to 0.1 volts. And number 1 is set to is hitting 0.3. When I say set up, it's touching right here. 0.3 here. 0.1 here. The difference is delta, which is 1.67 seconds. This is not a test right now. I'm just showing the cursors. This is just basically saying what I just said. Intersecting here and here, time difference. You can measure it right here. And these two also. Now, what you want to do is put the first cursor, it's cursor number 2. It don't matter which one you use, you just got to use both of them. This cursor, number 2, this one, You need to get this first cursor at 175 millivolts, as close as possible to it. The next cursor, you want to get to 800 millivolts, as close as possible to it. See, cursor number 2 right now, we at 100.1, but close to 175 millivolts. The next one, here, we got, see right here, we got this one. Oh, they switched it. You got this one at 175 millivolts, and this one at 800 millivolts. See how it connects here and connects here? The difference time, the delta time, is 107. That's a lazy O2 sensor. Remember, it got to be less than 100 milliseconds. And here is again the same measurement, same slide. And did another measurement, another sensor. Right here at 1, this one at 0.7. 102, still lazy O2 sensor for this one also. It's basically showing where it's connecting at. Right here, close to 0.8. This one is close to 1.1 or 0.175. Now here's another lab scope. This used 4 cursors to do it. Right here, the voltage scale is set to 2 volts per division. Right here is 2 volts. But in this particular lab scope, we got 1, 2, 3, 4 subdivisions. So this is 200 millivolts per division. Each subdivision is 50 millivolts per division. 50 millivolts, I should say. See, that's 200 millivolts. Each subdivision is 50 millivolts. Now I'm going to put my cursor at 175. Other one 800 millivolts. Then I'm going to interconnect 2 other cursors. 800 and 175, it failed. Now delta time is 380. Also a failed O2 sensor. Now it may still be switching, it's just lazy. Here's normal activity. This is what's supposed to, the front O2, these 2 up here. This is what's supposed to be happening. I'm sorry, this is not supposed to be happening. This is normal activity. Bank 1, sensor 1, bank 2, sensor 1. And we just grafting both the O2 sensors. Now this don't indicate how fast or slow it is. It's just telling you we do have activity on it. And it's like normal activity on it. Okay, that's on the O2 sensors. Any questions, let me know.